Hello everyone, welcome back to Science Simply, where complex doesn't have to mean complicated. You're running a 400-meter race on the track, alright? And you run a full lap, and the entire length of this track was 400 meters, alright? Now you cross the finish line and you're standing exactly where you started. How far do you travel? 400 meters, that's easy. But here's the question that kills people in exams. What was your displacement? Well, surprisingly, it's 0 meters. You ended where you began. That's it. And if you got that wrong or you weren't sure, then this video is exactly what you need because this one distinction is hiding behind every kinematics question you face. And by the end of this, you'll know the difference between distance and displacement and speed and velocity. And you'll be able to pull the right one out without thinking twice. Alright, let's get into it. So let's properly define distance and displacement. So distance is how far you've traveled in total. It doesn't care which direction you went. It didn't care that you turned corners, came back on yourself, zigzag. None of that matters. It's just a total path length. And that's it. Distance is a scalar. It has a magnitude only. So your distance can look something like this. And your distance will be the path length. Path length. Excuse the horrible handwriting. I'm on a mouse right now. So yeah, that's linear. It can be anything. It can go like this. It can go like this. Or whatever it is, it's a scalar. So direction doesn't matter. It just counts up. And obviously the unit's meters. And that's an SI unit. If we're thinking about CGS units, then it's centimeters because centimeter gram second. And SI is obviously meters. But now let's talk about displacement. So displacement is how far you are from where you started, measured in a straight line. And it includes direction. So displacement is a vector. It has both magnitude and direction. So here's a clear example. You walk 5 meters to your right and then 3 meters back to the left. Your distance, that's 8 meters. You walk 8 meters. But your displacement, that's just 2 because you're 2 meters away from where you started in a rightward direction. So let's try it out. So on a number line, usually, according to the sign convention, the right word is positive, left is negative. And this is the number line start from 0. So this is your initial position. You went 5 meters to the right? So 5 meters here. And you also went back 3 meters. So 1, 2, 3. You went back 2 meters. So you went like this. And then you go back 1, 2, 3. So how much do you move in total? Well, this is your initial position and the distance between your initial and final position is 2 meters. So ultimately your displacement is 2 meters. Alright? And now the unit is meters. It has to have a direction as well. So it's got to be north, it can be a negative, or it can be something like SXI cap plus SYJ cap. That's also a form you may see. And if you're thinking CGS, well, it's the same as distance, it's centimeters, right? So here's a worked example, all right? A person walks 5 meters to the right, 3 meters to the left. Distance is 5 plus 3 is 8 meters. But displacement, you take the direction in account, and obviously leftward is negative and rightward is positive. So it's ultimately 2 meters to the right? So distance is about the entire journey. Displacement is a shortcut between the final position and the initial position. And the shortest path between them is the displacement. So, for example, let's say that a person took this path, right? Now, distance can be the total path length, but what is the magnitude of the displacement? Well, this basically forms, let me erase that. This basically forms a right angle triangle because if this is the final position, let me make this a bit better. So if this is the final position, if it's a right angle triangle, this is the initial position, final position, it's on the same number line, forms right angle triangle. This is SX, this is SY, and ultimately you get S equals the square root of SX squared plus SY squared. Again, these are just formulas I'm throwing out, but just use your brain. You don't have to follow everything blindly, alright? So let's do a practice problem. A student walks 6 meters north and turns around and walks 6 meters south. Basically what happens is they walk 6 meters and they turn back 6 meters. A, we're going to solve A part first, the distance. So distance, well, first they walk 6 meters and then they walk 6 meters south. Now I don't care about direction, distance is a scalar. 6 meters plus 6 meters, 12 meters. Now what's the displacement? Well, this is where it gets interesting. So S, well, let me just draw the vector symbol. So first it's 6 meters north. Remember how we took j cap as the vertical direction, right? And negative negative j cap is this direction and positive j cap is this direction. So we're going to say that 6 meters north is just positive 6 meters j cap and 6 meters south is minus 6 meters j cap. Now this does become 0 meters j cap, and if you do 0 in any directions it's 0, so 0 meters is the displacement. Alright, they ended where they started, that's why there's no net change in position, and distance is total path length, so you just add both lengths. Alright, now the displacement of 0 does not mean nothing happened, they still travel 12 meters, but it's just that within that time frame, the position didn't change, so displacement also doesn't change. Alright, this is very simple. Now let's use the same logic to define speed and velocity. So speed is how fast you're moving. So it's basically the rate of change of distance. So how much distance are you covering per unit time, right? The scalar, no direction. Velocity, it's how fast and which direction. So velocity is the rate of change. If you set displacement, that's incorrect. It's the rate of change of position, and you'll see why. So speed uses distance, velocity uses displacement. Alright, so here's the formula. Speed is distance by time, velocity is displacement by time. Now note that it's displacement. Now displacement itself is the change in position, right? X is usually noted as the position, so you don't need to calculate the change in displacement because displacement itself is just a change of position, right? Remember how in this part the position here was 6 meters north and then they went back to 0. So in the same way here, the first the position was 5, but then they went back minus 3, that's 2. So, and we also use the X symbol right here, right? And also in this diagram. So that's why you don't use change in displacement, although you can if it's required, but usually you're not going to have to use change in displacement, you'll just find the displacement. But displacement is a change of position, and that's why you can also say that um, the velocity vector is equal to the final position minus initial position by time, right? Because you're changing the position per unit time. Alright, and obviously time taken is a scalar because time doesn't have a direction, right? So let's do a worked example. So a car travels 300 meters in 20 seconds. So we know that the distance here, because there's no direction, right? It just travels that much length. The time is 20 seconds. So speed, which I write by capital S, is basically d by t. They wrote it as d divided by t like this, but in exams you're most likely gonna have to write it like this. So it's 300 meters by 20 seconds, which is equal to 15 meters per second, and that's how you write your speed. Now here our displacement is 300 meters due north. Now in the velocity you're going to have the same in the same direction, right? Because the velocity direction must be same as the displacement direction, right? Because it's going in that direction. But um sometimes you need not write north. It's assumed that north is positive always and south is positive negative unless you change it, which can happen, but that's a bit more complicated and we'll come to that when it comes in the course. But for now, we'll just take north as positive, so as this is 300 meters, and then the time is what, 20 seconds, right? So velocity is again s over t. Notice I'm not writing the vector symbol um because it's not a vector. It's just a quantity, right? 300 meters. Anyway, 300 over 20, 15 meters per second. Yeah, the reason we didn't write a vector format is because we didn't write a formal unit vector as a direction, right? But if you're saying like, s is equal to 2 I cap plus, oh actually wait, let's just do it as the example here. It's 300 meters north, so it's 300 meters j cap. Then you write the vector symbol. Why? Because using a unit vector as magnitude. Let's do this again. This is your turn. Let's see how we can solve this question. So first, graph the speed. So here, distance is 500 meters. No direction scalar. Time 25 seconds. S is d over t. 500 meters. 25 seconds. That's 20 meters per second. Now, velocity is a vector. 500 meters due east. So on the horizontal number line, rightwards or east is usually positive, and leftwards or west is negative. Since it's east, I'm just gonna write it as 500 meters. You can also write as 500 meters, I cap, but that's just overcomplicating it. Was not really required, so I'm just writing as s equals 500 meters, right? And time is 25 seconds. So v is equal to s over t, which is the same as 500 over 25 seconds, 25 meters per second. Note that there's just a positive sign, but that indicates the direction is east, right? But let's say if I did it like this, 500 meters I cap, and then time is 20 seconds, then this just becomes 25 meters per second I cap. Right? Same thing, just you gotta use your brain a bit. Right? Simple. Here they said that here they said that it's east. If you're using north, south, east, west, it's very good. But usually, eventually, you're going to have to get used to using I cap, J cap, and K cap because those are the three dimensions that we know. And if we're dealing with vectors that are dealing with three-dimensional motion where they're going in multiple directions at once, then you're gonna have to ditch this this 2D plane thing, right? We'll come to that eventually. It'll take some practice, but don't be afraid. Let's zoom out for a second because the scalar versus vector thing isn't just relevant here. This runs throughout all the physics, and speed and velocity, distance, displacement, these are all very basic examples, but eventually you're gonna have to learn when we get into dynamics using force. All right. So let's just rewind. So scalars have magnitude only, distance, speed, mass, temperature, all those are scalars. Vectors have magnitude and direction, and displacement, velocity, force, acceleration, all those are vectors, right? So when you see a vector quantity in an exam, direction is not optional, it's part of the answer. So missing it means dropping marks. Not because the examiner is being harsh, because without direction, the vector is genuinely incomplete. Right? So think of it this way. If I told you to drive 10 kilometers, you have no idea where to go. But drive 10 kilometers north, now you know exactly what to do. And that's the difference between a vector and a scalar. Right? Let's wrap this up. Distance is the total path length. It's a scalar, so no direction needed. Distance is the straight line distance from start to finish with the direction. It's a vector. Speed is how fast, right? How fast and how quickly you're covering distance. It's a scalar. Velocity is how fast and which way. So velocity is how much are you covering the displacement length per unit time, right? And in any exam answer involving a vector quantity, always see the direction. Whether that's by taking unit vectors like I cap, J cap, K cap, if it's part of your school syllabus or exam syllabus, or if using positive or negative, or using north, south, east, or west, whatever, the direction must be there. Alright? So drop a comment below. Which one trips you up the most? Mixing up distance and displacement or forgetting the direction and velocity answer? Alright? And if this helped, the next video covers the graphs. So distance time graph, displacement time graphs, velocity time graphs, speed time graphs, including how to find the slope of the graph and also how to find the area under the graph and what's the point of even doing so in the first place. So subscribe if you want to see it. I'll see you there in the next video. Peace.